All right, welcome. Let's talk about Charles's law, which is V1 over T1 equals V2 over T2. And that's when you have some sort of sample that the volume and temperature are changing, but everything else stays the same. So like a balloon where the number of moles stays the same and the pressure stays the same. So you'll see this line here, the N and P, number of moles and pressure stay the same. So you change the volume, you change the temperature, just like in the lab, you heat up a balloon, it gets bigger, you cool it down, it gets smaller. They are directly proportional. So let's look at the equation here. You have a 14-liter party balloon, that's volume 1, at room temperature 23 degrees Celsius. What we need to do is we have it in Celsius, we need to convert it to Kelvin. Why? Because you can end up with 0 Celsius or negative Celsius, and that just messes up your whole numbers because you can't have a negative volume if you're multiplying or dividing, or infinite volume. So we use the Kelvin scale because the Kelvin scale, the coldest temperature is 0. It'll always be a positive number, I guess after 0. And let's keep on going with our question here. So we have our volume 1 and we have our T1. What volume will the balloon be? So they're asking us for our V2. If we take it outside where it's freezing in the SF summer at 0 degrees Celsius. So change that to Kelvin. 0 degrees Celsius plus 273 is 273 Kelvin. We have all of our numbers. Write out the equation. It's really important that you write out the equation every time. So you get it right. V1 over T1 equals V2 over T2. It's really easy to flip these. Put the units in. 14 liters over 296 Kelvin. V2 over 273 Kelvin. Always have the number with the unit. Just never take them apart. They love each other. So to solve this, it's cross, multiply, and divide. So this times this divided by that. Notice how the kelvins cancel, and you end up with liters. So it's this times this divided by that. And your V2 is 12.9 liters, which is pretty cool, right? So you cool it down. Pun noticed. You cool it down from 23 from room temp to 0, and the volume goes down. But what about if, what temperature will you have to heat the balloon if you want it to grow to be 20 liters? So say you want the balloon to be even bigger. So let's find out what temperature you have to heat it to. So V1 over T1 equals V2 over T2. V1 is 14 liters, T1 is 296 Kelvin, V2 is 20 liters, and T2 is who knows. So the important thing is notice how it switched from the last one. Now we're solving for T2. Same procedure, cross, multiply, and divide. Dun, dun, dun. Notice how the liters cancel. This times this divided by that in your calculator. Boop, 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 boop. 423 Kelvin. And if you wanted to, if that doesn't mean anything to you, switch it to Celsius. So 423 minus 273 is 150 degrees Celsius, which is 50 degrees above boiling, which is pretty hot. So maybe you have to put in some oil or something. All right, that's it for Charles's law.